When you go to the phlebotomist and when they take your blood in a vial, they put a stopper in it, and a lot of times there's a little bit of wax stuff kind of down here in the bottom. And by the way, that's like citrate or something like that. It's a preservative. And that's just to keep your blood from decaying as it's given time to be taken to the place to be analyzed. And so what happens is that they take this blood and they put it into a machine that kind of has these slots that are angled kind of like this and maybe like this, and then this spins around in a circle, and it's a centrifuge is what it is. So as this spins around in a circle, all of the heavy parts of the blood go to the bottom, and so that's what we see in your blood. The heavy part, which are your red blood cells or the hematocrit, goes to the bottom when it's spun out. And of course, there's a stopper in this. This is not done open. And then the rest of it winds up being plasma. And so basically about 55% of your blood is plasma, and roughly about 45% is hematocrit, and then the middle layer is the buffy coat. And the buffy coat is called this because that's where the white blood cells kind of wind up landing on top of the blood, but heavier than the plasma. And matter of fact, as a note of interest, I learned today that the ideal blood plasma donor is AB negative, and it's AB because AB blood doesn't have any antibodies because it has both markers. So that plasma would not have any antibodies to go to another recipient donor. As far as blood goes, O negative is the universal donor, and it's because O, even though it does have antibodies to A and to B, it could be donated if it's in a small amount and donated slowly to the recipient. And the negative would mean that there would not be anything in the blood that would trigger an RH response in the recipient. And we're going to get to those in just a few minutes. Now, let's talk about clinical aspects of this right here. For a female, 45%, that's really high. I would say for a female, matter of fact, your book says that 40% is normal, but I would be willing to say that a healthy female that's really healthy for a female. I've even heard of females having a 12. Wow, that's like 1/3 of the amount of blood cells that you're supposed to have. So what's the deal? You're a lady and you've got a monthly blood loss, and instead of eating some red meats, or I don't want to even talk about liver, but instead of eating some dark greens like spinach and trying to get this boosted back up, you keep going to the chicken place, and that's not really doing the trick to really build your blood back like it needs to be. And so you just get more and more weak and tired. And that's called what? Anemia. Okay? So you can have a hemorrhagic anemia from a monthly blood loss, and then because you're not getting the B vitamins, the B12 in the red meats that you're eating, you can have a pernicious anemia. There are different kinds of anemia. And remember, if you don't have enough blood cells, then you're not transporting oxygen in your body, and if you don't have enough oxygen, you're going to feel tired. Now, another thing, just as a sideline that I'm going to say, since I'm talking about this, is if a person would train in a high altitude, like in Denver, then what would happen is, because they don't have enough oxygen carrying capacity at that higher altitude with lower oxygen, their body would build more blood. Then coming back down to a lower altitude and competing in a lower altitude would give them an advantage in oxygenation over a person that just normally trained on the plains. And that is the illegal aspect of that is sometimes people will have their blood removed and then they'll build it back for a few months, and then at the time of the competition they'll have it put back in their body, and that gives them more oxygen capacity. The problem is it also makes more stroke volume going through the heart, and I've heard of people actually dying from blood doping is what that's called. So an interesting thing having to do with blood and oxygen carrying capacity. Remember that it's the hemoglobin that carries your oxygen. It actually has a greater affinity for carbon monoxide than it does for carbon dioxide or oxygen. So therefore, if you are exposed to the waste products of combustion, then that can actually bind up and just about ruin some red blood cells for a while. Remember, it takes 120 days for these, their lifespan is 120 days. So if you get a bunch of red blood cells locked down by carbon monoxide, it's going to take a while for those to die and for new ones to replenish the body. That's what I know about blood today. That I forgot to say is that in the blood there are non-protein nitrogenous substances. There are urea, waste products. That's an obvious product of protein metabolism that has to be eliminated in the kidneys, and if a person is not eliminating this properly in the kidneys, then they can get toxemia or uremia of the blood. Too much of this can cause toxic effects. Eclampsia is the word, or preeclampsia.